A heat engine is a device that operates in a cycle to convert heat into work. A heat engine absorbs heat QH from a hot source, does work to the environment, and expel wasted heat QC to a cold source. So the work done by the heat engine to the environment equals to the net change of heat transfer. So equals the heat absorbed from the hot source minus the heat expelled to the cold source. And the efficiency of the engine is given by the work done, which is what we want the engine to do, the work we want the engine to do, divided by the heat we need to absorb from the hot source. And the work done is QH subtract QC. So we want this efficiency to be higher. So what we want is that we want this QC, the wasted heat we expel to cold source, is as small as possible. Then we will have a very efficient engine. A heat engine can operate in reverse. In this case, energy is injected to the engine from a cold source. And then we can do work to the heat pump. So we can expel heat into hot reservoirs. And this is exactly how refrigerator and heat pumps works. Is heat engine running in reverse, and they use work to remove heat from a cold area, such like inside of the house or inside the refrigerator, to a warm area. So what AC works is that we remove heat from the house to the outside. Refrigerator works to remove heat from inside the refrigerator to outside of the refrigerator. Let's use refrigerator as an example. So inside the refrigerator, we have liquid freon. Liquid freon would evaporate into gases. Would evaporate into gases, thus absorb heat from the food inside of the refrigerator. And then they will go to a compressor. This compressor will compress the gas phase of freon and make it extremely hot, but it stay as gas. And then it will go to the outside. So these are the coil we see. Those are the coil we see here. Because it's a very, very hot gas, it's hotter than the room, so it can radiate all the heat out to the room. And then we're going to use some expansion device. It will become liquid freon again inside the refrigerator and complete the cycle. So you see freon is doing a phase transition inside the refrigerator, absorb heat from the refrigerator and expel the heat to outside of the room, even though refrigerator is much colder than the room. And the coefficient of performance for refrigerator on air condition is given by this equation. The work we need to do is W the heat we absorbed from the cold area is QC. Now, if we're running in heating mode, then it's heat we absorb from the hot source divided by the work done by the heat engine to the environment. Here is the second law of thermodynamics. It says it's impossible to build an engine that is 100% efficient. You must always have some waste heat. To put it into layman's word, the first law means you can't win, so energy is conserved. The second law means you can't even break even with the energy for the heat engine.